My name is Yulia. I'm a group data development manager in Israel, AppsFlyer. So, who is... Does it work? Okay. No, but it doesn't work. Okay, I'll move it that way. No problem. Who is working here with big data? Raise your hands. How much is your big data? 10 petabyte? 15 petabyte? No? Let's take it 20 petabyte. So what would you do if I'll ask you to delete one row out of your 20 petabyte? Do you know how to find it? Do you know how to delete it if you found it? What would you do if I'll say to you that you will receive 20 million euro fine if you don't do it? So we are now 18 months after the law was enforced, 2 years after the bombshell was dropped. And we actually realized that we need to implement a technically complex problem. Now it looks like a good time to stop and make a retrospective. We will look back into our initial assumptions, actual implementation and deployment, optimization and results as we saw them during those 18 months. So in my talk, we will talk a little bit what is GDPR and why it is so important to us as individuals and for businesses to comply. We will talk what is the complexity of GDPR implementation in the real big data environments. And we also will see the real implementation of GDPR. So we are TopFlyer, a world's leading platform for mobile attribution and analytics. We provide app marketeers insights that they can plan, optimize, and create new campaigns for user acquisitions or retargeting. How they do that? We actually help them to understand what was the user advertisement journey before user installed the application itself. So we collect clicks and impressions from ad networks, and then all user engagement inside mobile application, and then we match this data with the user advertisement journey, providing our customers with this information so they can compare different channels and partners and campaigns and their performance. Let's imagine that you have some application and you want to promote it. So you define few channels and define campaigns in those different channels. Let's take Facebook and Google. And now you see the performance of those users. You see them buying something inside your application. You see them installing and erasing this application immediately from their devices. So how can you compare between those two channels? With our insights, since we connect this information with advertisement journey of users, our insights help app marketeers to compare those campaigns. A little bit about the volumes and scale at AppsFlyer. So we are receiving 100 billion events on a daily basis, seeing at least 2 billion daily users. Our data warehouses contain 60 petabytes of data, growing daily by 80 terabytes. Our annual growth is more than twice. So we are the real global big data company. So I'm a development manager at AppsFlyer, but I'm also a private person. And it is very interesting to me what happens with my personal information when I'm surfing on sites, like any other person here in this room, in the city, on the continent. At AppsFlyer, we gather personal information about users and provide this information to our customers so they can make significant decisions with their campaigns. But let's imagine that it is your personal information, and you might not wish for us or our customers to collect this information and use it. 18 months ago, you actually didn't have any control over this situation, and that's what GDPR comes to solve. On May 25th, 2018, a new data privacy law called GDPR, General Data Protection Regulation, was enforced with the primary objective to help people in the European Union to protect their personal information. But what is this personal information and why it is so important? So many companies collecting a lot of information about us. And in my example, they just segment us by audiences, for example, by age, gender, area of interest, location, and then use these audiences for targeted advertisement that has proven its efficiency for audiences. That's why this information is so important to many businesses. A little bit about terms in GDPR. The personal information, or PII, is a personal identifiable information. So, which rights do we have as individuals? First, as an individual, we have a right to access any company to provide any personal information that they collected about us. Second, we have right to change this information if it is incorrect. Third, we can require any company to erase any personal information that they collected about us within 30 days. This right is called right to erasure or right to be forgotten in GDPR terms. It looks very naive and simple, but it is going to be a main focus of my talk today. We also have a right to choose which company will have an access to our personal information and will be able to use it. And we also have a right to require any company to stop gathering any personal information from now on. This one is called right to object. All right, now we are aligned with GDPR basics, and let's talk a little bit about the business side. So not complying with GDPR as a business was simply not an option. First, the GDPR applies on all companies acting inside the European Union, even those that do not have physical representation in the European Union. Second, lack of compliance may cause high penalties and very high fines with the potential to kill the business. But let's put aside the fine. We at AppsFlyer collecting very sensitive information about users, and we continuously improve our security and take care very carefully about our potential data leaks. These are just few examples about companies that fail to comply with GDPR. Everybody in this room, I hope, heard about the business and Facebook and Google leakage. And we'll talk a little bit about Ticketmaster. They reported in June 2018, they reported about the data breach that is exposing personal information like names, emails, and payment card details of more than 40,000 users. Now they are the subject of £70 million fine. But not all businesses were born equal in eyes of GDPR. Some of them are directly interacting with users, collecting and using their personal information. Those are called data controllers. Data controllers might transfer this personal information to other platforms, and those are data processors. There is no direct relationship between the user and the processor. In my example, the user interacts with the mobile app, which is processor, and the mobile app transfers this information to analytics platform like Google and AppsFlyer, and user may actually not be aware about our existence in the loop. Okay, now we are aligned with all GDPR concepts, and it is a good time to deep dive into AppsFlyer architecture and actual implementation. So, as I already said, we receive clicks and impressions from ad networks and all other user interaction with an application from our SDK. Then all those events arrive to our servers, and the real attribution mechanism is fired. Once we find a match between every event arrived to our system with an advertisement journey like click or impression, this is an attribution, we save this data into the attribution database based on AeroSpike with the help of Redis. Then all those events are sent to Kafka message queue to other services. And from this point on, the data will be saved into two separate data stores. Google BigQuery for raw data reporting and internal BI, and AWS S3 data lake based on Parquet files for batch processing and further data investigations. So, having two separate data stores and a huge amount of data and a huge amount of unique users make the erasure request pretty impossible. We actually need to find the row, randomly find the row, and delete random row out of our store. Imagine that we are in 80s. Our data volumes are very small, and they allowing us to save everything in a relational database. In this case, user deletion is just a simple search in the index table, and then cascadingly deleting this user out of other tables, right? Very simple. But modern volumes are much, much bigger. And all modern data warehouses like BigQuery, Parquet files, Redshift, they rely heavily on append-only manner of writing and data immutability. They also, most of them, do not support random access, and more than that, random row deletion. But we still need to implement the GDPR. So the first step is to start mapping your stores and understanding where the user's PII may appear. In our case, it is Aerospike, Redis, Kafka, BigQuery, and AWS S3 data lake. Then you need to find those stores that will store data for more than 30 days. When we have Redis and Kafka that store data very temporary, only for a few hours, while others like Aerospike, BigQuery, and Parquet files are more likely to save data for more than 30 days. Those are potential GDPR problems, and we will take care about each one of them. So we started with AWS S3 data lake, and a number of possible solutions were suggested, and we will talk about each one of them and their advantages and disadvantages. The first one was, let's save PII data aside separately, and the rest of the event details in the event table. When every event arrives, we need to check if the user of this event already appears on the users table, and if not, we will add this user. And then we will save the event details aside on the raw data event table without PII. But as I said, we already have 2 billion users on unique users on a daily basis. And actually, we see almost all users in the world during the months. I want to ask you one question. Do you think you have AppsFlyer SDK on your phones? Yeah? How many?
I think it's all applications.
It was 2 or 3 person. Do you have smartphones? How many of you? Most probably you have our SDK on your phone. And most probably it's more than one application on your phone. So we see all of you, OK? So this table is going to be very, very big. But let's talk about the advantages. The deletion of user is very simple. We just need to find this user inside the user table and delete. Simple. Another significant advantage is that the PII data is stored separated, and then we can harden and sharpen our security around this table, and the leakage will be very minimal if it can appear. But as I already said, every data store in our systems has multiple purposes. So multiple consumers should be adapted to a new data architecture. We made some kind of effort estimation for this work, and it was 1 year for all our data engineers. Another thing, that at AppsFlyer we provide our customers with raw data reports, where we export a big amount of data in one piece. In this case, with this approach, we will have to take a big table of raw events and join it with a big table of users, right? And this huge join will be very expensive and will not always work. So we ruled this solution out. And then another one came. We suggested to take the PII data and store it inside the data, but encrypt every row with per user key. In this case, the deletion is still simple. We need just drop the encryption key. The data will be there, but it will be encrypted with the key that we don't know, so it is inaccessible. But the join is still the same, right? We will take the data with the encrypted PII and join with the table of encryption keys, which is of the same length like a unique users table. And now we added the complexity. Now we need to decrypt every row with its own key, which is insane, right? So another disadvantage was that saving the encrypted data for long months with the synchronization to decryption keys is very fragile, and we have a potential to damage our production data. So 3 is a charm, right? So we suggested the third one. The third one was just scan fully all our data. If the user arrives, we will scan all our data, find where this user appears, and just clean this PII from these files. We didn't change our architecture, but who said that we can scan 60 petabytes of data? Nobody. How much will it cost us? I don't know. So our assumption was that we will have tens up to hundreds deletion requests during the months, which is not a catastrophe if we don't have too much data to scan. So we looked closely into our data, and we found that most of users appear only in small amount of files. So if we somehow will know on each user in which files this user appears, we will scan only those files, and the problem is solved. And that's what we ultimately implemented. This is our data structure. We have a unique device ID, application context, PII of the user, and the rest of event details. And then, on a daily basis, we create an index. It's some kind of a phone book, but the user has links on which files this user appears. This is not a simple process. First of all, we need to scan all our data again. Actually, we scan only 2 columns, the unique device ID and the application context. That's where Parquet files help us to save money and cost. Second, our index process should be familiar with all data types schemas. At AppsFlyer, we don't have unified schema for all data types. And the third problem is the synchronization between the data and the user index. Sometimes, due to production bugs or some maintenance activities that we make, we have to rewrite our data again, and then the index is outdated, and it needs to be regenerated automatically. How we delete the data, actually. We collect all users that requested to be forgotten in a specific period of time. Then we go to our index and find all files that those users appear in, copy those files aside to the temporary storage, run Spark in order to clean all PII of users that requested to be forgotten. Then we run a number of tests. First, we check that the files were not damaged. Second, we check that all PII data that should be deleted was actually deleted. Then we check that all PII data that should not be deleted is still there in the files. Once all tests are running successfully, we return those files back with the same name. There are a few reasons to have those files with the same name. First, S3 doesn't support atomic operation on files overwriting. So it's according to the order of operation that you will do, just delete the file and then write the new file with the new name. Or first, new file write the new file with the new name and then delete the old one, you have a potential of data damage, right? Or data duplication or lack of data if something happened in between. We use AWS S3 versioning in order to make this operation atomic. Actually, versioning creates the new file and delete the old one atomically for us. And the second reason is the fact that we have a connection between the data and the files this data appears in, like this index, or any other metadata store that we might have in future. And if we will write the file with the new name, this connection will disappear and we will need to recreate the index. A little bit about numbers and cost. So we see now 400,000 of erasure requests monthly, which is 8 million files, more or less, 1 petabyte of data to scan and clean. I cannot share here our expenses and cost, but you can understand that this process is very expensive. So if you remember our assumption of having hundreds of erasure requests monthly, we missed our mark big time. But taking into account other solutions, we still think that this approach works best for us now. So we talked about AWS S3 data lake, and now let's talk a little bit about the BigQuery approach. We have the data, and we save this data in separate tables according to the data types, partitioned by days. So if the user arrived to AppsFlyer on a specific day, we are sure that user's PII will appear on those partitions and will not appear on others. By using the same index from the previous example, we find all partitions, dirty partitions, that the users that require to be forgotten may appear in. We gather those partitions, and then we run a simple delete query that BigQuery support on those partitions only. We submit those queries asynchronously. BigQuery allows us to run those queries on low priority resources without damaging production. If one of those queries fails, BigQuery notifies us about this failure, and we will just rerun it again. So in the beginning, we thought that we will have small amount of users, so we wrote very naive delete statement, the up run. Then when the number of users started to grow, we always hit the maximum number of characters in the statement, and we changed it a little bit. We load all users that requested to be deleted in the temporary table, and then some kind of delete join them from it. All right, this was a BigQuery. I will not talk about the arrow spike because arrow spike is not a problem for deletion. It's a key value store, and it actually does support random row deletion. So this one is simple. So for the conclusion, I hope that you understood better what is GDPR and why it is so important to implement it for businesses, and why it is so important to us as individuals. I hope that you understood why the GDPR implementation in big data environment is so complex, mostly due to data immutability and lack of random access. You also saw the pragmatic approach and the real example of this implementation. And if you are standing before planning a new data lake, or you want to change your own current data lake in future, I have two advices for you. First, you need to take a better close look into the AC transaction management. At AppsFlyer, we are now comparing three of them: Hoodie, Delta by Databricks, and Hive with ORC format. And the second, you need to take care about the user distribution inside, data distribution inside your data files. If your user information distributed between many files, you will need to touch all of them in order to delete users' PII. So this one is very important. I was asked to add this slide in order to write the session, so please write it when it is still fresh in your minds. And this is a good time for questions. Thank you very much.
question. When you have a user on multiple devices, are you able to, when someone asks to opt out, are you able to detect all the devices that they're and delete all the personal data you have from all those devices?
Okay, I need to repeat the question. Okay, so the question was, if we have the same user on different devices, do we know if it is the same users and if we need to delete and if we know how to delete all this information? So we, as I said, we are the processor. So the user doesn't know about us. Who knows? The mobile application. So they have to know that the user requested on different devices, and they have to transfer to us the user's GDPR request for each one of those devices.
You guys are a data management platform, right?
Yeah. Any other question?
Yeah.
Sure.
Hello. 400,000 requests per month. What is it request? It's request, for example, me ask application on you to delete my information.
Yeah.
Personal information. It's very popular in Europe, really.
So first of all, you are asking not us, you are asking applications to delete, and they transfer to us this request. It's very popular, and actually, if you remember, on May 25th, 2018, I received all my Facebook and all my LinkedIn, everything was popped up with those GDPR. If you remember the playlist of I call my number, forget my number, if you remember that. There was one application that was very funny. It called Ship Your Enemy a GDPR Request, where you can add your personal details and choose a company that you hate. Just send them the GDPR request because it's very expensive. Yeah. Okay.
I had a question, actually. You were talking about tests, that you should really test your files. Do you have maybe a story to tell of how you figured that out? Or did you have this idea from the beginning?
No, I can say that the question is that I talked about the tests and how we came with the idea of all those tests from the very beginning. What were the reasons of those tests? So, for example, about the damaged files, 3 or 4 months ago, we had a problem with one of our servers processor that read data and failed to read one of the files. And then we didn't understand what happened. And then we found that this file was involved in one of the GDPR erasure requests. Fortunately, we had on the versioning, the previous version of this file, because the deletion of this file happened a few days before. So we took this file out of the versioning and put it back, and cleaned and put it back. But yes, it happened in real production. All those tests came actually from production bugs.
From experience.
Yeah.
Yeah, so in the first approach, you said we were going to consolidate all the PII data into a couple of tables, and then also do some hardening around those tables so that it's less likely that the information will leak from them. But in the final approach, you decided to just not do any of that,
yeah,
and take the data model as is. So did you, in essence, conclude that the amount of security you had around your entire application was enough to also be secure enough with PII, or did you take extra measures because of the GDPR and the PII thing?
Okay, so the question was that in one of the solutions that we suggested, the PII was aside, and it is a good approach for security, right? And in the final solution, we actually saved the PII inside the data, which is not optimal for data security. So the answer is that implementing GDPR for the first solution was very, very hard. Actually, we need to adapt all our consumers that are using this data. All our BI engineers need to understand how to collect this data. This is going to be very expensive and change our production, actually. So we decided that we'll take the regular approach, like what we took, but being the processor, we are not exposed to the end users. So our data security is good, but not every user can request us to give the data. Only our consumers can talk with us. So our security is very, very sharp, but it's not. We are not B2C company. We are B2B, so it works other way.
Okay.
Yeah.
I guess related to that, if you were starting now, which option would you prefer between like the second option?
Yeah. So we grew very fast actually. With our numbers, you see that when I joined the company 4 years ago, we had 3 billion events daily. Okay, so we grew very fast, and our data architecture still needs some adaptations to do. What we do now is we change the files ordering. This is until end of the year will be in production. We change the manner of how we save the data in the deep storage. So we will touch less files when we delete. And the second one, we have huge amount of consumers. So we need to adapt all of them to the new architecture. The second one actually changes entirely how you read the data and how you write the data. So this one is very, very difficult to come with, but this is also in progress now. But today, as I said, still this solution is best for current data architecture. Yeah. Any question? Thank you very much.